Alright, this is homework, page 84, 35 to 51 odd. I think y'all had 36 to 52 odd, and then you had some odd problems that I already did on the PowerPoint, on the video from yesterday. So here we go. Alright, we have number 35 is x plus 9 is less than 3. And the directions say, solve and write the solution set using interval notation. So first we need to solve. In order to solve, we're going to subtract 9 from both sides, giving me x is less than negative 6. We don't have to graph it, but it's going to make it a heck of a lot easier for us to graph for us to write an interval notation if we graph it. Remember, since it's negative numbers, it goes smaller to larger in the left direction, so be careful here. It is just less than, so we're going to do open circle the old way. Since our variable is first, we're going to shade in the direction of the arrow. Open circle is the same as parenthesis. Okay, so we draw our parenthesis. Now we're going to write our interval notation. Remember, we read a book from left to right. So we're going to start at negative infinity. Negative infinity always gets a parenthesis. We go to negative 6. Our graph has a parenthesis, so our interval notation has a parenthesis. So we're negative infinity to negative 6. Okay, here we have negative x is less than negative 4. So we're going to divide both sides by negative 1. When you divide an inequality by a negative, you need to flip the sign. So it was less than, now it becomes greater than. And a negative divided by a negative is a positive. So we're going to go ahead and graph this. So we'll do our 3 tick marks. We've got 4 and 5 and 3. It is again an open circle because it's just greater than. Because our variable is first, we shade the direction of the arrow. Again, it's a parenthesis because it's just greater than. Now let's go ahead and write this baby in interval notation. It's a parenthesis on the graph, so it's a parenthesis in our interval notation. We start at 4. The graph goes on forever, so it goes to infinity. And infinity is always a parenthesis, so it is 4 to infinity. Okay, here we have negative 7x is less than or equal to 3.5. We're going to divide both sides by negative 7. When we divide by a negative, we flip our sign, so it was less than or equal to. Now it's greater than or equal to. I am not sure what 3.5 divided by negative 7 is, so I'm going to go ahead and punch that into my calculator. 3.5 divided by negative 7 is negative 0.5. So we're going to go ahead and graph this. So we're doing negative numbers, so I'm going to do 0, negative 1, negative 2, negative 3. We'll go ahead and do half tick marks. So negative 0.5 is going to be right here. We're going to do a closed circle, since we're talking about greater than or equal to. Since my variable is first, I'm going to go ahead and shade the direction the arrow is pointing. And remember, guys, when we're talking about the arrow, we're talking about right here. And you can go ahead and draw this and make it look like an arrow. Since it's pointing this direction, we're going to shade this direction. We don't use closed dots anymore. Now we use brackets. So we're going to turn that closed dot into a bracket. Since we have a bracket on our graph, we use a bracket in our interval notation. So our interval notation says negative 0.5 to positive infinity. Positive infinity always gets a parenthesis. And that's it. Alright, now we're dealing with some fractions. So we're going to have to go ahead and use an LCD. So we have 2, 3, and 6. So we're going to go ahead and write LCD over here. And remember, you always start with your largest denominator and see if all of them go into it. So I come over here, I write my largest denominator. Does 2 go into 6 evenly? Yep. Does 3 go into 6 evenly? Yep. Does 6 go into 6 evenly? Yep. So that's nice. Our LCD is just 6. So we're going to multiply 6 by each piece. We say 6 divided by 2 is 3. 6 divided by 3 is 2. And 6 divided by 6 is just 1. So now you've got 3 times 1 is 3. Plus 2 times 2 is 4. Is greater than or equal to 1 times x is just x. Combine your like terms, you get 7 is greater than or equal to x. So let's go ahead and graph this. Now remember, so we're going to put our 7 here. So we've got 8 and 6. You can do one of two things. You can either be a flipper, or you can say this time the numbers first. So we're going to shade the way that the arrow is not pointing. But remember, I'm a flipper. So the butt of the inequality is facing towards the x. So when I write my x first, the butt of your inequality stays facing towards the x. Okay? So it's less than or equal to, so it's going to be a closed dot. Now that I wrote my variable first, I'm going to shade the direction the arrow is pointing, which is this way. Change my closed dot to a bracket. And now I write it in interval notation. Since it goes all the way to the left here, I know that means negative infinity, which always gets a parenthesis, and it goes to 7. There's a bracket on my graph, which means I get a bracket in my interval notation. So it's negative infinity to positive 7. Alright, so the first thing we're going to do here is distribute this negative 4. So I have negative 5x plus 4 is less than or equal to negative 4x plus 4. It's plus 4 because negative 4 times negative 1 is positive 4. Now I want to move my smaller x to my larger x. This one's actually the smaller x because they're both negative. So you do the opposite. It's negative 5x, so I'm going to add 5x to both sides. So I have 4 is less than or equal to negative 4x plus 5x is just x. Now we're going to go ahead and isolate my variable. So I'm going to subtract 4 from both sides, which gives me 0 is less than or equal to x. Okay, so let's go ahead and graph this. I've got 0, I've got 1, and I've got negative 1. Now again, I'm a flipper, so the mouth this time is open towards my x. So I'm going to put x here. I'm going to open the mouth up towards it. It's going to be a closed circle on my 0. Now that I put my variable first, I'm going to shade the direction the arrow points, which is this way. A closed circle, closed dot is the same as a bracket. So I bring my bracket down at 0. It goes on to infinity, and infinity always gets a parenthesis. Okay. Alright, we want to go ahead and get rid of this fraction here. So remember, you want to multiply 4 by both sides, but you need to make sure to put both sides in parentheses. This 4 and this 4 cancel. So on the left, you're left with 3 times x minus 7 is greater than or equal to, and you're on the right, you're left with 4 times x plus 2. Go ahead and distribute the 3. Go ahead and distribute the 4. Leaving 3x minus 21 is greater than or equal to 4x plus 8. Bring your smaller x to your larger x. So I'm going to subtract 3x from both sides, leaving me negative 21 is greater than or equal to x plus 8. Now you're going to isolate the variable by subtracting 8 from both sides. Negative 21 minus 8 is negative 29, which is greater than or equal to x. Again, my numbers first. I'm a flipper, so I like to flip it. In this case, the butt of the variable is towards the x. So I'm going to make sure the butt of the variable stays towards the x. It is a negative 29, so be careful. This will be negative 28, and this will be negative 30. It's a closed circle because it's less than or equal to. And I'm going to shade the way the arrow is pointing. Okay? It's a bracket now instead of that closed circle. We graduated from the closed circle to the brackets. Okay? My arrow is going all the way to the left. That means negative infinity, right? Negative infinity always gets a what? A parenthesis. It's going all the way to negative 29. There's a bracket on my graph, so my interval notation gets a bracket. So it is negative infinity to negative 29. All right. First things first, we're going to combine our like terms here. We have 0.8x plus 0.6x, which is 1.4x, is greater than or equal to 4.2. We're going to divide both sides by 1.4. Can't do that one in my head, so I'm going to use my calculator for that one. So I've got 4.2 divided by 1.4, which is going to give me 3. So I've got x is greater than or equal to 3, not 2. I'm not sure what happened there. So I'm going to go ahead and graph this. 3 goes in the middle, 4 and 2. It's a closed dot. My variable's first, so I shade the way the arrow's pointing. Change my closed dot to a bracket. And you can go ahead and stop drawing those closed dots from now on. You can go ahead and make them brackets if you want. Now my graph starts with a bracket at 3, goes on forever to the right. So that's infinity, and infinity always gets a parenthesis. So it is 3 to infinity. Ooh, this one looks fun. Okay, first thing we're going to do is distribute here. Distribute here. We have 4x minus 24 plus 2x minus 4 is greater than or equal to 3x minus 21 plus 10x. After we distribute, we're going to combine like terms. 4x and 2x is 6x. And remember, cross them out as you use them so you don't get confused. Then I've got negative 24 minus 4 is negative 28. Cross them out. I know I used everything on the left is greater than or equal to 3x plus 10x is 13x. Cross those babies out. Minus 21. So I combine all my like terms. Now I'm going to move my smaller x to my larger x. Which one's smaller? 6x is smaller than 13x. So I'm going to subtract 6x from both sides, which gives me negative 28 is greater than or equal to 7x minus 21. Isolate my variable. I'm going to add 21 to both sides, giving me negative 7 is greater than or equal to 7x. Divide 7 from both sides. Scoot this up a little. You get negative, you get negative 1 is greater than or equal to x. Since my number's first, I'm going to go ahead and flip it. The butt of my inequality is towards the x. So when I rewrite it, make sure the butt of the inequality is towards the x. Okay, graph it. It's a negative number, so make sure that you're putting everything in the right order. Now this time I'm not going to put my dots. It would be a closed dot, right? But instead of a closed dot, I'm going to go ahead and use my bracket. So I'm going to shade towards the way the arrow goes. So that means my bracket's going to go ahead and go this way, right? And I'm going to shade this way. I don't need that closed dot anymore. We're going to try to get away from it. Okay. So it's going to be negative infinity because we're all going all the way to the left, right? Negative infinity. And I come all the way to negative 1. It's a bracket on my graph. So it's a bracket in my interval notation. Okay. Negative infinity to negative 1. All right, last one here. We're going to distribute here and distribute here. So we have 14 minus 5x when we distribute that negative to the 5x. And then negative to negative 6 gives us positive 6. Is greater than or equal to negative 6x minus 6 minus 5. Negative 6 times x is negative 6x. Negative 6 times 1 is negative 6. Combine your like terms. 14 plus 6 is 20. Cross those out. Minus 5x, nothing to combine that with, is greater than or equal to negative 6x, nothing to combine that with. Negative 6 minus 5 is negative 11. Cross those bad boys out. Now we're going to move our smaller x to our larger x, right? Which one's smaller? Actually, in this case, the negative 6x is smaller. So we're going to do the opposite. We're going to add 6x to both sides, leaving me 20 plus x, because negative 5 plus 6 is 1, is greater than or equal to negative 11. Now we're going to isolate our variable. We're going to subtract 20 from both sides, giving me x is greater than or equal to negative 31. Got another negative number here, so be real careful. This is negative 30, and this is negative 32. So this would normally be a closed circle. I'm not going to do a closed circle. I'm going to go straight to my bracket. It faces this way because my variable's first, and my arrow's pointing this way. Bracket on my graph, bracket in my interval notation. Starting at negative 31, going forever to the right, which means infinity. Infinity always gets a parenthesis, and that's it. You have completed the homework. Congratulations. Have a great night, and I will see you guys tomorrow.